Have you ever wondered where your variables actually live when you write Java code? What happens when a method finishes or when an object is no longer needed? And what is this where keyword everyone keeps talking about since Java 10? Today we will deep dive into variables, data types, and Java's memory model, which is one of the most crucial concepts every Java developer must master. So if you are new to my channel, if you haven't yet subscribed to my channel yet, please do. Now let's kickstart this video. So let's start with variables because this is like the core concept and very basic thing that everyone should know about. And in any of the programming language, we would create a variable. So just like every other programming language in Java, this is a named memory location. Now, what do we mean by that? So this variable holds a value in layman terms, right? So a variable holds a value. Now, where does it hold that value? That is in a location. Now, what is that location? That is a memory location. So that location could be your heap or any other memory area. So usually a variable always comes within this syntax. So the first is going to be your data type, the type of the data, then your variable name, and then comes the value which is actually going to reside in the memory. All right. So we are going to talk about data type in later part of this video, but currently we are talking about variables and value. So let's take an example. So a data type could be int, it could be a double, and it could be a string as well. All right. So let's suppose we have a variable name age and it holds a value 25. Double variable name as salary, and this can hold value like this. Similarly, we have a name, and let's go with my name. So my name is Prashant. All right. So this is your variable. So when we declare a variable, the compiler reserves memory according to its data type. So just to give you an example, int reserves 4 bytes, double reserves 8 bytes. Now a string is not actually a data type. So it is a class in Java. So it reserves a reference to an object stored elsewhere in memory. All right. So we will talk about these, like what are these, in later section of this video. But currently you got the understanding that a variable is something which holds a value in a memory location, which could be your heap. Now it variable name needs a data type. So it can be int as in a primitive data type, a double, which is another example of primitive data type, then string, which is a class. So for a class, this is a reference and these are your variable names. This is the actual value which gets stored in the heap, in the memory. All right. Now let's talk about data types. So data type, why do we need data type in Java? So this is not something related to Java. So like other programming languages that we have, Java is also statically typed. Just to give you an example, Python is not, but Java is. All right. So when Java is statically typed, it means that every variable type must be known at compile time. So we cannot do a equals to 25. This is not allowed, and this will give you a compilation error. So it needs to be something like this. Then only your compilation will pass. Now we have two separate type of data type. We have primitive and then we have reference. We will talk about both of them. So let's talk about primitive first. Alright, so these are the 8 different types of your primitive data types. So we have byte, which is your first type. Then we have short, int, long, float, double, char, and lastly we have boolean. Now they hold a different memory area as in a byte in memory. So if you create a byte variable, this will only have 1 byte memory. All right, now with short it is 2, with int 4, and similarly we have different types of byte allocation. Now we have different default values. So every integer type value holds the default value as 0. So as you can see here, we all have zeros. For float as well, it is going to be 0, but as it is going to hold a decimal value, it will be something like 0.0. Same goes for double. For character, it holds a character. That's why we have this default value here. Boolean again is going to be either 1 or 0, as in true or false. So the default value is false. All right. So these all are your integral data types. Then these are your floating types. This is character and this is logical. Now these are the simplest building blocks. So we store them directly in memory, not as objects, right? So each primitive type defines how much space it takes and what values it can store. So if you have a data which is going to store just 1 byte, then use byte. All right. You cannot store a value which is having 4 byte of data in your short variable. This is not going to be allowed and you will get a compilation error. Now this was all about primitive type. Now let's talk about reference data type. So reference type is everything else apart from your primitive types. For example, it can be an array, it can be a class, an interface, and it can be a string object that we have already seen. So this everything is going to be your reference type. So these do not hold actual values. These store memory addresses. So that is why we call them reference. Alright. So memory addresses are your heap address, which it stores basically. So for example, if we have string city equals to Dehradun, which is my favorite city. So this city stores a reference to a string object. So this is your object, which is going to be in heap memory location. Now this is an object and this city is a variable. Now this variable holds the memory address of this object. So that is why we call this reference type, because reference type do not store the data directly. They store the address of where that data lives. On the other hand, primitive data types hold the actual values. That is why we need 1 byte or 2 byte or 4 byte rated information, so that compiler can judge what data we are actually going to hold inside this variable. Alright, now let's talk about Java memory model. We have seen the architecture of JVM. Now comes Java memory model. So Java memory model has two main memory areas. We are going to cover basically these two. So first is your stack and second is your heap. Alright, these are two major areas. Now what is heap, what is stack? So stack we already know, it's like last in first out. So that is what it follows, right? Remember this, right? So the same structure we follow here. So it is like a bucket where you insert first value, then second value, then third value, and so on. So this is first, second, third, and the value which is at the top is going to be popped first. That is what LIFO says. Now what exactly are we talking here in terms of Java memory model? So first is that stack stores method calls. Now method calls includes your local variables and references to objects in heap. Alright. Second, so each thread has its own stack area. So for example, public static void main is the main method in every class. This is again a thread. So it has its own stack. Now this is automatically managed. We don't have to do anything here. Now when we say managed, it means that we get the stack area automatically, and so the creation of this stack area is done automatically. Same goes for deletion. So we don't do anything. So when the method ends, as in the execution of method ends, the stack area is automatically destroyed for that method. So let's take an example of stack here. So let's say that you have a method test, and inside you have a variable which is your local variable 10. So this is your primitive. So primitive data types, as in your local variables, are stored in stack, not in heap. Now when you have student s equals to new student, let's say Raj, then this is going to store in heap, and this s is going to be in stack. So this is going to store the memory address of this heap object. Alright, so when test returns, the stack frame is popped. So it is going to pop out from the stack, and the variable a and reference s will be gone. But the student object in heap stays alive if it is still referenced somewhere else. And if it is not referenced somewhere else, then this is going to be eligible for garbage collection. Alright. Now let's talk about heap. So we already know now that heap stores objects. Alright. And objects include, let's suppose, your array, or you can say instance variable. We will talk about instance variables also. Now this heap is shared between all the threads, and this is managed by GC, garbage collector. So this is not automatically managed, this is managed by GC. So whatever algorithm you have used for GC, that matters a lot in terms of performance. So just to give you an example, if this student is not referenced anywhere else, and if it is eligible for GC, garbage collection, then this doesn't mean that this is going to be picked immediately for collection, and the area that this object is using in terms of memory is going to be cleared. That doesn't happen automatically and immediately. All right. Now moving ahead. So what to summarize here? So we talked about stack and heap. So you can say that stack is like your desk, quick access but temporary. And same goes for my office desk, because anyone can sit on my desk, it is not permanent. Now heap is going to be like your storage room which you book, as in, let's suppose, in a bank. So storage room is shared, right? It is persistent, but it can be slower. So that is why I said that if your GC algorithm is not efficient enough, this can get slow, very slow. Now let's talk about types of variables. I told you that we will talk about instance variables. So this is the time when we will talk about that. So we have three types of variables. So first is your local variable. We talked about it. So local variable is a variable which is stored inside a method. Second is your instance variable, which is declared or created outside any method. Then you have static variables, which are created in a static block. So it can be a static block or it can be a static method. Alright, so let's go slow. Let's start with local variables. So local variables, like I said, are declared inside a method or maybe a constructor or any other block. Now local variables are always going to be stored in stack. So these will be created when the method or constructor or block is getting executed, and this will get destroyed when the method is completed because it is automatically managed. Alright, I don't think we need to see the example again for this, but just to give you another example, let's say if you have a method greet and if you have a variable message, and let's suppose the value as namaste. So this is your local variable. Alright, so here message exists only when greet is executing. Once the method returns, its stack frame is gone and message will be deleted. So the object namaste may still live in the string pool if referenced elsewhere. Otherwise, it is again eligible for GC. So string values are always going to be in string pool, and string pool is going to be inside heap. Alright, so this is very important. Remember that string pool. So just to summarize now, local variables live as long as the method runs, or even shorter because modern JVMs optimize them away if not used further. Now let's talk about instance variables. So instance variables are declared inside a class but outside any other method. So these will always be stored in heap, and creation and deletion will be handled by GC. Alright, not creation but deletion will be handled by GC. Now to take an example here, so you can say that if we have a class car and on top you have a variable string color, so this is your instance variable. So as long as the object of this car exists and if it is reachable, the instance variable exists. When this object becomes unreachable, then GC will reclaim color. So to summarize, instance variables live as long as the object lives. When the object is gone, its instance fields vanish with it. So when I say object, I mean car C equals to new car. And with this variable, you can call color. Alright, now let's talk about static variables. So static variables are declared with a static keyword. Alright, now this is going to be shared across all objects of the same class. So this will be stored in class metadata, which is tied to a class loader. Now taking an example, we always use a static variable whenever we require that you don't have to create an object of this class. So we use static keyword int, and let's say max users equals to 100. So this is your static variable, and to call this you can directly do config dot max users. But in the example of instance variable, we needed to do car C equals to new car, and then we can use C dot color. Alright, so this is a major advantage. Now static variables live as long as the class is loaded. In most cases, this means for the entire JVM lifetime, as in your application runtime. But in plugin system or web servers that uses custom class loaders and not your application class loader or system class loader, so in those cases when the class loader is unloaded, the static variables are garbage collected as well. So just to summarize, static variables live as long as the class is loaded, and usually that is until your application shuts down. Let's talk about var keyword. So this was introduced in Java 10 and we can use it in any Java 10 plus release. So var keyword enables local variable type inference. So var lets the compiler infer the variable type from its initializer. For example, before Java 10, I used to do string name equals to Prashant. Now we already know here that this is enclosed in double quotes. So this cannot be character. This has to be string. So why do I have to specify string here? So if I could have used var here, this should be justified, right? This is one of the way of using var. Similarly, we used to do array list string list equals to new array list string, right? So here we know that this is going to be of type array list. Why do we need to specify this here? We could have easily replaced it with var and this would have worked. So this is the functionality behind your var keyword. So there are some rules of using var keyword. So let's talk about that. Otherwise you will get a compilation error. So what are those rules? So rule 1 is must have an initializer. This is a must. Now what does this mean? If you have var x, this is not allowed. It should be something like var x equals to 10, so that we know that this is going to be integer. Now your second rule is cannot be used for fields, parameter as in method parameters, fields as in your instance variables or any static variables, or return types. This should be for a local variable as in inside a method only. Then not allowed for null initializer. So we cannot do var x equals to null. This is not allowed. Then like I said, this is for local variables only. Alright, so just to summarize, var keyword makes your code look cleaner without making Java dynamically typed. The type is still fixed at compile time. So just to summarize, we had local, stance and static variables. You can also have var keyword, so another type of variable. So local stores values in stack memory location, instance stores it in heap, and static in class area, which is again heap. So local lifetime is until method exists. Instance lifetime is until object is garbage collected. Static lifetime is until class is unloaded. Now for default value, local doesn't have any. Instance depends on the type. Same goes for your static. So think of it like this. Local variables live and die with methods. Instance variables live and die with objects, and static variables live and die with the class. Now there could be some questions asked on these topics. So one of the question could be, where are local variables stored in memory? It should be stack. What is the difference between primitive and reference type? So primitive hold a value in as in the data object, but reference type doesn't. It just holds the reference of the already created object in the heap. What happens when an object becomes unreachable? That would be garbage collected, right? How long do static variables live? So they will live as long as the class object exists. When it dies, then static variable also dies. What are the limitations of where? It must have an initializer. It cannot be used for fields, parameters, or return type. It cannot be initialized with the value null, and it must be used with local variables only. So if you found this video helpful, hit like, subscribe, and check the next lecture where we will deep dive into other Java topics. So thank you very much for watching. I hope we will meet you in some another video. Till then, stay happy, keep learning, keep coding, and stay curious. I will see you in the next video. Thank you and bye bye.